Hey, what's up, Titans? Welcome to some math. Yeah, interesting times, huh? Well, happy you're here joining me. I've got homework answers for you for the Bootcamp review. If you have a specific question you need help with, just go ahead and skip ahead to that question. Otherwise, go ahead and watch them all. I mean, what else do you got to do, right? Nothing. Hopefully you're staying at home. All right, so number one, we've got multiplication. We know it's multiplication because we don't have a plus or minus in between the two parentheses, so we're going to multiply. And when we multiply, we use our box. So I'm going to put my 5x minus 4, and then on the other side of my box, the 3x plus 6. Or your teacher might refer to this as the area model, or the area box. To fill each box, we're going to multiply the terms that go with that box. So for this one, we're going to do 3x times 5x, which is 15x squared. This box here is going to be negative 4 times positive 3x, which is negative 12x. This box down here, positive 6 times a positive 5x, which gives us 30x. And then finally, negative 4 times positive 6 gives us negative 24. Finally, we're going to combine like terms and take these terms out of the box to get our polynomial. We always start with the largest exponent, so we're going to start with the 15x squared. But then we do have like terms with our negative 12x and positive 30x, which if we combine those gives us positive 18x. And then finally, we've got our constant, negative 24. So some review on vocabulary. This is called a trinomial because it has three terms. Its degree is 2 because that's the largest exponent. The coefficient, just some vocab here, throw some extra practice in there. The coefficient on this is 15, so that's the number in front of your variable. The coefficient on this one is 18, and then the number at the end with no variable attached to it is called your constant. So the constant on this one is negative 24. I go ahead and look at my answers, and voila, there it is. Next problem, we have another multiplication problem. 2n minus 8, 5n minus 4. Make sure you have that minus next to your 4 so you know it's a negative 4. Also, if you put the 5n minus 4 up here and the 2n minus 8 over there, that's totally fine as long as you keep the binomials together. Either order will work. So as we go ahead and fill out our box, 5n times 2n is 10n squared. 5n times negative 8, negative 40n. Negative 4 times positive 2n is a negative 8n. And negative 4 times negative 8, when we multiply two negatives, we're going to get a positive. In this case, positive 32. Then we take our terms in our box. We're going to pull them out, combine like terms. Largest exponent goes first, so 10n squared. Combine our like terms, which gives us negative 48n. And then finally we have our constant plus 32. So 10n squared minus 48n plus 32. Number 2 is A. All right, number 3. This is one that can sometimes trip you up a little bit if you're not careful. 2a minus 5 squared means we really have 2a minus 5 times itself. So we're going to write another 2a minus 5. And just like the two problems before, we're going to use our box to multiply. So 2a minus 5 and 2a minus 5. And let's get to work. 2a times 2a is 4a squared. 2a times negative 5 is a negative 10a. 2a times negative 5 is another negative 10a. And then negative 5 times negative 5 is a positive 25. When we combine like terms on this one, we have to be a little bit careful. Sometimes when people see negative 10 and negative 10, they cross them out. But if you have negative 10 and you combine that with negative 10, you actually have negative 20a. So we just have more negatives. And then finally, we've got the plus 25. So 4a squared minus 20a plus 25. That one was B. Moving on to the next one, we have 3x plus 1 times 3x minus 1. This one's going to actually be a little bit unique. Put my 3x plus 1 on top of my box. 3x minus 1 on the side. And just like all of our other multiplication problems, we multiply our boxes or to fill in our boxes, 9x squared, positive 3x, but now I get a negative 3x, and then finally negative 1. This time when we combine like terms, we still have our 9x squared first, but this time we have positive 3x and negative 3x, which if we combine positive 3 and negative 3, they add to 0, so we have no x's. We don't have to put it down, there's nothing. And then we go to our constant, which is negative 1. So 9x squared minus 1. Moving right along, now we're getting to some big boxes. P plus 3 times 4p squared minus 6p minus 7. We have a binomial times a trinomial. All that means is our box is going to be larger. I usually do mine where they're longer, and so I put my trinomial on top, 4p squared minus 6p minus 7, and then I can put my binomial on the side. But again, if you prefer to put your trinomial along the side and your binomial at the top, you'd still get the same answer. So now I'm going to divide it. I've got 2 terms, so I've got 2 rows. Up here I have 3 terms, so now I'm going to have 3 columns, which gives me 6 boxes instead of 4. But what we do next is still the same. To fill in this box, I'm going to do 4p squared times p, which is 4p to the third, because I really have p to the 1, and with exponents, we add the exponents as we multiply. Negative 6p times p is going to be negative 6p squared, because that's really 1 and 1, and we add those together when we multiply. And then finally, we have p times negative 7, which is negative 7p. To get my bottom row, 3 times 4p squared is 12p squared. 3 times negative 6p is negative 18p. And 3 times negative 7 is negative 21. So just like the other boxes, we're going to combine like terms. We're going to start with our largest exponent so that it's in what we call standard form. Standard form, we go largest exponent and then smaller exponents after that. So I've got 4p to the third. But then we do have like terms, negative 6p squared and positive 12p squared, which add together to make positive 6p squared. Notice we don't add the exponents when we're combining like terms. We only add the exponents when we multiply. So at this point, when we combine those, we now have 6p squareds. We have more like terms here, negative 7p, negative 18p, which makes a grand total of negative 25p. And then finally, we have the constant, which there are no other constants, so we can't combine it with anything, and we put negative 21. So 4p to the third plus 6p squared minus 25p minus 21. Bam, number 5 is D. Moving on to number 6, we've got another binomial times trinomial. Same thing we just did, just a bigger box, right? So I'm going to put my 3k squared minus 4k plus 5. Oop, made that a little skinny, but that's all good. And then my binomial, 7k minus 2. And we're going to fill in our box. 7k times 3k squared is 21k to the third. 7k times negative 4k is negative 28k to the second, or k squared. 7k times 5 is 35k. Continue on with the negative 2. So negative 2 times 3k squared is negative 6k squared. Negative times negative will give me a positive 8k. And then negative 2 times 5 will give me a negative 10. Finally, we go look for our like terms. We've got 21k to the third. We can combine our k squareds, which gives us negative 34. We can combine our k's, which gives us positive 43k. And then finally, we've got our constant, minus 10. So 21k to the third minus 34k squared plus 43k minus 10. Nailed it! 6 is B. This is pretty weird doing this with none of you here, but hope you're having a good day. I'm going to continue on to the back page. Addition. Addition problems become very simple because all we have to do is combine like terms. We know it's an addition problem because we have the plus in between the two polynomials. And so all we can really do is combine like terms. So I look for my largest exponent, which is a to the second. So I've got 4a squared. There's no other a squareds to combine that with, so I'm just going to write that down as my leading term of my polynomial. Then we look for a's. I've got 6a and positive 3a. So 6a plus 3a is 9a. And then I can look for my constants, which I have positive 6 and negative 4. And if we combine 6 and negative 4, that's going to be positive 2. So our new polynomial, once we simplified these, is 4a squared plus 9a plus 2. 7 is C. 8 is where usually a few more problems with subtraction, because some of us forget to distribute that negative. Depending on your teacher, we may teach it slightly different. But essentially what I do is this first polynomial isn't going to change. That's what we're subtracting from. So I'm going to write down the 5a minus 2. But everything after that, everything after the minus sign, we're going to change the sign because we're going to subtract each of those. So if I subtract a positive 8a squared, that's the same as minus 8a squared. If I subtract a positive a, that's the same thing as doing minus a. So I'm going to put minus a. And then finally, if I subtract 4, that's minus 4. So you'll notice my three terms here are just the opposite of what they were in here. All three were positive in the trinomial, but because we're subtracting them, all three will change signs and all three became negative. And once we do that, we're back to a problem just like addition where we're going to combine like terms. So I've got negative 8a squared. That's my only squared. Then I look for a's. I've got 5a and negative 1a. So I have to make sure I include that sign. 5a minus 1a is a positive 4a. And then finally I go to my constants. I've got negative 2, negative 4, which those combine to make negative 6. So we end up with negative 8a squared plus 4a minus 6, which is once again C. Number 9, I know this is an addition problem, so I'm only combining like terms. And once again, I know it's an addition problem because we have the plus in the middle. Some people like to do the lines underneath like I've been doing to show like terms, or circle to show like terms. Some of you might prefer to use different colors to show your like terms, so I'll show an example of that. On this one, I can start with my largest exponent, which is 6x squared. I can combine that with the other x squared, which is negative 2x squared. And if I combine those like terms, that makes 4x squared. And then some of you might decide to take a different color and go to your x's. There I've got positive 1x, negative 3x. 1 minus 3 is negative 2. So we have a total of negative 2x. And then finally, I can go to my constants. I've got negative 6, positive 5. Negative 6, positive 5. I have more negatives than positives, so it's going to be a negative 1. And there's my final answer, my simplified polynomial, 4x squared minus 2x minus 1. So again, whether you underline stuff or circle stuff or use colors, it doesn't matter. Just make sure you combine like terms together. Number 10, we're back to another subtraction problem. So again, I'm going to rewrite my original polynomial because that one is not going to change. But the second polynomial, we're going to subtract everything that is inside of that polynomial. So we're essentially distributing the negative. So instead of 4x squared, we're going to do minus 4x squared. Instead of positive 4, we're going to do minus 4. And then instead of 5x, we're going to do minus 5x. So that's a negative 5x. And then now that I've distributed that negative, I can go ahead and combine like terms. I've got 4x squared minus 4x squared, which last time I checked, that is 0. They gone. Then I can go to my x's. I've got positive 8x and negative 5x. So 8 minus 5 is 3. So that gives me 3x. And then last but not least, I've got my -2 and -4, which gives me -6. So we end up with a grand total of 3x minus 6. All right, we're getting close. Now we're on to solving. All right, anytime we solve a quadratic by the square root method, we're going to get the squared part by itself. So on this first one, the n squared is the only thing on that side, so the squared is by itself. To undo the squared, we're going to take the square root of both sides. The squared and the square root cancel each other out, which gives us n. And then anytime we're solving, when we take the square root of a number, we're going to put plus or minus. And then hopefully we know the square root of 36, or plug it in your calculator if you need to. Square root of 36 is 6. So we don't just get +6, we also get -6, which gives us 2 solutions. So these are called quadratic equations because the largest exponent is 2, and you'll find that these equations can have as many as 2 solutions. So this one did have 2 solutions. It was +6 and -6. Moving on to number 12. We got a similar problem, but this time when we take the square root of both sides, 20 is not a perfect square. So we're going to go ahead and simplify the radical. Again, your teacher may do this differently than I did, but hopefully you can kind of follow what I'm doing. So I break it down into a factor tree. I can do 2 times 10 to get 20. Since 2 is a prime number, I circle it to show that I can't break it down. But 10 I can still break down to 2 and 5. 2 and 5 are also prime numbers because we can't break those down. So once I have only prime numbers, I look for a number that has a pair. I think Mr. Wood says something like, if you got a pair, it makes a square and you can take one out. I do it where I've got my radical, which is the house, and in order to leave the house, you have to have a buddy. So the 2's have a buddy, so they get to go out and play. But poor 5, no buddy, he's got to stay inside. So we get 2 root 5. But again, because we're solving, we have to make sure we do plus minus. So in the end, we get k equals plus or minus 2 square root 5. So not 2 square root 5, but plus or minus 2 square root 5. So this one we pick D. All right, on to the last 2 problems. This time we have some more going on. Other than just the term squared, we have 7n squared minus 10 equals 18. And before we take the square root, we want to get the n squared alone. So before I'm going to take the square root, just like any other equation, I'm going to add the 10 to get that away from the variable. And then I also need to get rid of this 7 because the 7 is not getting squared, only the n is getting squared. So I'm going to divide both sides by 7, which leaves me with n squared equals 4. Now that the squared is by itself, I can take the square root of both sides, and n equals positive and negative square root of 4, which is 2. So positive 2 and negative 2. So again, quadratics, we usually get 2 solutions, so don't get tricked into picking the one that only has 1 solution. This time we can do positive or negative 2. How do I know we can do both? If I plug in positive 2 or if I plug in negative 2 for n at the beginning of the problem, either one when we plug it in will work. So they both are solutions. All right, the last one. We've got 5n squared plus 7 equals 97. Similarly, before we take the square root, we need to get the n squared by itself. So subtract 7. I still got that 5 sitting there that I need to get rid of. And since that 5 is multiplied, we're going to undo that by dividing. 90 divided by 5, I'm pretty sure that's 18. We'll find out in a minute if I did that right. And then finally, we can take the square root, which 18 is not a perfect square, so we're going to do our factor tree. I can do 2 times 9, and then 9 I can do 3 times 3. I look for my pair or my buddies. I've got a pair of 3's, so the 3 gets to come out, but the 2 stays inside. And because we're solving a quadratic, we're going to have positive and negative 3 root 2. So positive 3 root 2, negative 3, right? 3 root 2. Bam, bam, thank you, ma'am. Hope you were able to learn something from that, and look forward to seeing you again soon.